SIOTH is a modular web-based platform that's easily accessible through a desktop shortcut after a simple setup process. All configuration needs are unified in one window. After logging in with your account, you will be welcomed with the home page. You'll find 4 main panels: Application Configuration, Unified HMI Designer, Unified HMI Runtime, and User Management. To begin configuring your application, the first step is to create a project and then establish a data flow. Here we have an existing project with a pre-configured data flow. The data flow module is a feature that enables data integration and consolidation from various sources across multiple sites. It supports a wide range of industry-standard communication protocols and brokers, including Modbus, OPC Classic, OPC UA, MQTT, SQL-like databases, and data historians like SIOTH PI. Building your data flow is as simple as dragging and dropping connectors from the toolbox and establishing connections. Configurations of the connectors are easily reviewable and modifiable. All connectors are firewall-friendly, all ports can be configured, come with built-in encryption, support for DMZ architectures, and data buffering capabilities. Here we have an example of a source Modbus connector. We see that any connector can either be a source to publish data or a destination to subscribe to the data. Moving to the tags configuration window, the user has to configure the data that will be retrieved and published. In this existing subscription, we can see that the connector will be getting the data from this Modbus device, which in our case would be the Modbus slave. The following in the Modbus device configuration correspond to this simulator. For the data tags, they can be added by importing a CSV file. You can download the template and modify to correspond to your actual configuration. After importing your tags, you can add or modify them in the tags management table. All our source connectors on the left side have similar configurations, with slight differences from one to another. We can see that the source connectors are linked to different destinations and that all of them are linked to an OPC UA server. Within the UA server configuration, you can browse all the points added from the source connectors, as we can see here. You can also enable historical data using OPC UA HDA and configure alarms and conditions for any data point. The alarms configuration includes thresholds, severity levels, and note messages. Going back to the OPC UA server configuration, you can find the endpoint to connect to the server, and you can set security modes and user authentication types. We have here an OPC UA client that we connected to our SIOTH OPC UA server. We can see the different nodes that we configured from our source connectors. We are now able to access our data from multiple sources using a single OPC UA endpoint. In another example, you can send your data to historians and databases like we see here using SQL Server as a destination connector. To define your SQL Server, a device must be created with the corresponding configuration. After that, you can simply select the table where the data will be stored and configure the mapping between your source tags and your table columns. We can see now that we have our incoming data being stored in our database. Similarly to the OPC UA server, we can also link our source connectors to an MQTT broker to expose the data in a single endpoint. When connecting to the SIOTH MQTT broker using our defined configuration, we can see our data incoming in real time. Let's now see an example of adding a new connector from scratch. We simply navigate to the toolbox and drag and drop the connector of choice. I'll add here another instance of the Modbus connector. We have the option to change the configuration or keep it as default. In this advanced configuration section, other options are available for the user. For example, here we'll change the publishing topic name. Moving on to the tags configuration, we'll add a new subscription and then create a new device to connect to our Modbus slave. We can fill out the configuration and save to create our device. After that, we can change the publishing frequency or change the publishing mode, and then we'll import our list of tags. We can download the template and fill it out, or if we have it prepared, we can just import it directly. Then we'll save our connector's configuration, and we'll see how simple it is to send our data to the destinations. By simply linking our source connector to the destinations, saving the data flow, and starting our new connector, we should see the new data incoming. Here in our same MQTT broker, we can see a new topic on which data is being published, which corresponds of course to our new Modbus connector. And in the OPC UA server, if we check our nodes, we'll find that the new Modbus connector was added and we can see the real-time data. If you want to go beyond data collection and transform your data into actionable knowledge and build intelligence, calculations, or trigger events based on given conditions and notify users of those events, the answer is the Job Engine module. You can visually create rules and logic using a drag-and-drop interface. For example, you can set up a rule using the toolbox blocks to automatically control your energy mode for an HVAC unit. Let's understand the logic behind this rule. We can see that the energy consumption is being calculated by multiplying the power and the operating time of the unit. The toolbox offers a variety of tools for data control to read and write data from and to SIOTH and to apply functions and logics. A quick example from this logic is setting the mode to energy saving when the energy consumption exceeds a certain threshold. To further put your data into context, SIOTH offers the Data Model module. This module allows for structuring and organizing your data by creating classes and instances to build assets hierarchy. For example, we have this HVAC instance which was created from defined class that we later see. These instances allow you to map equipment properties to tags from any deployed connector in the SIOTH data flows. These same data model instances can be used, as we saw in the Job Engine rules, to apply our required logic. Data can be read from, or set to, the data model attributes. We can see here that the mode was set to energy saving following the logic from the rule that we created. Let's discover how the classes behind these different instances were created. We have here multiple defined classes. Let's see, for example, this equipment class. It includes the definition of the different attributes as we've seen in our generated instance earlier. We mentioned earlier that we can map instance properties to tags from any deployed connector in the data flows. We can see in this example an instance where the attribute reading is mapped to a Modbus tag from our previous data flow. The data is displayed in real time as displayed here. Let's see another example of a rule where we can send notifications to end users. In this example, we are comparing temperature readings against thresholds and sending email notifications when the thresholds are passed. We can also trigger events that can be used to start other rules or workflows. SMS message blocks are also available to send notifications. Let's go back now to the home page and explore the UHMI module used for creating end-user dashboards and SCADA interfaces. Let's start with the runtime environment and navigate through this existing application. In this overview page, we can see different kinds of data being displayed using different graphical controls. All this data is incoming from SIOTH and from other external sources. In the following, we have a configured SCADA interface where we can see real-time data. We also added this switch to send write commands to our source devices through SIOTH. We've mapped this switch to a certain Modbus tag. We can see that we can write onto this tag through SIOTH. Let's see other dashboards in our application. We have here an interface for OPC UA alarms. We can see here real-time alarms and historical alarms as well. We can set the time period from which we want to retrieve alarms and select filters for priorities and states. For real-time alarms, we can see details, acknowledge the alarms, or shelve them. Another type of dashboard is this health monitoring interface, where we can have an overview on the health and the status of our data flows. We can see here some resource consumption metrics for CPU and memory consumption. Let's move now to the UHMI Designer mode and see how these dashboards were configured. After opening our application, first thing would be to define our data sources. We can add SIOTH as our source, as we can see here, to get all the different types of data that we have seen earlier. Then, for the dashboard, we can find those in the interactive views. We can see the SCADA example that we just saw. Let's see, for example, how the switch was mapped to SIOTH tags. We added an event that will set the Modbus tag to the emitted value from the switch, which is a tag from this device that we used in the data flows earlier. To define how the runtime will look like, we need to configure the layout. You can add or remove sections like the header, footer, or sides. After completing the configuration of your UHMI Designer, you can click on Publish to deploy your application in the runtime environment. This was a quick walkthrough of SIOTH. We hope it gave you a fair idea on the capabilities of our software.